why it is confusing. Okay? Because there are some formula written down there that we don't know where the formulas are from. Right? Determine the normal stress and shearing stress at point A and point B. That's the easy part. What I'm going to do more than that. Okay. So we know. Okay. So let's write from here. I have 15 emails asking me to do this question. Okay. That's why I'm doing this question. So we know that D on the outside is 45 times 10 to the power minus 3 meter. And D on the inside is equal to 35 times 10 to the power minus 3 meters. Okay. And we have to calculate the cross-sectional area. Is it 42? Yes, thank you. So the cross-sectional area is straightforward, is 4, or I'm going to address this as A. It's equal to 423.33 times 10 to the power 6 meter. For this is easy. The second moment of area, I, is equal to 79.083. And just remember, J is equal to 2I. So this will be equal to 158.166 times 10 to the power minus 9 meter 4. The next one is QX is equal to A Z bar. Okay. So what this means is still the rule complies that the first moment of area cannot cross the what? Centroid. So if this is our centroid, this is the area that we have to take. And over here, this is our Z bar. Okay. Or not so high up, sorry. Let me draw it slightly lower. Okay, not so high. Okay. So we have our Z bar. So we know that our area is equal to pi r squared. Okay. And Z bar will be, or not, the area is equal to pi r squared. The area is pi r squared over 2. And then Z bar, some students derive it, okay, which I was really impressed, is 4 over r over 3 pi. Okay. And these values are not cross-sectional area. If I have to give you formula for cross-sectional area, there's something wrong. Okay. This will be provided. Okay. I don't expect you all to derive. Okay. If there's any value like this that you don't know, it will be provided. Okay. So from here, we know that QX is equal to the cross-sectional area is pi r squared over 2. The Z bar is 4 over 3 divided by 3 pi. So when you cancel them, what you get, so you can cancel 2, you can cancel pi. So this will become 2r cubed over 3. That's why when you look at the solution manual, it seems confusing. where is the pi? Yes or no? So the pi disappears from here. So from here, we can calculate like QZ or QX is equal to QZ, okay, because it's circle. So we know that this is equal to 2/3 outer diameter squared minus R, sorry, inter radius cube, not squared. Okay. So all you need to do now is just put the numbers in. So you have 42 times 10 to the power minus 3 over 2 cube minus by 35 times 10 to the power minus 3 over 2 cube. So at the end of the day, this will be equal to 2.6011 times 10 to the power minus 6 meter cube. Okay. So this is the part that a lot of students ask me why this formula. Okay, so I've just told you why. Right, this is the easy part. The not so difficult part is now we have to look at this structure. Okay, and some of you probably forget. Okay, hey, what happened to me now? Okay. So remember what I taught you guys, right? We are going to break this down in different point of view. Okay. So the transformation, for this case, we are given a transformation that this is our X, Y, and Z. Okay. And then we are trying to solve. So we are going to look at the XY plane first. Okay. So we look at the XY plane. So we know that this is rotation about Z. So just sketch it out. Okay, again, this is a sketch. So after the sketch, you put in your forces. So we have 1200. You have your 1500 Newton. And then like what I told you before, you put in where the element, okay, so this is your element A, and this is your element B. And then more important, you put in the axis where the element will be affected. Okay, so this centroid is relative to the what? Element. Okay. So from here, we know that we are going to have a PY, right? If PY is not so obvious, don't worry. Maybe another point of view, we then talk about PY, okay? So remember what I told you, focus on the what? The arrow, okay? Ignore the dot and the crosses. So over here, we know that we are going to have a member or a moment in the z-axis, right? So this moment in the z-axis will be equal to 1500. And the force of 1500 is parallel to the what? To the centroid of interest. So this is the distance. So this distance is 0.045. Okay. So multiply by 0.045. So this will be equal to 1500 times by 0.045. It's equal to 67.5 Newton meter. But do something further than that, okay? So from here, you know that when you calculate normal stress, which is equal to Y, this is equal to mz over izz, okay, multiplied by a distance x. Okay, so when you do this, you know that at element A is equal to what? 0. Start your analysis, okay? Don't daydream, okay? In your exam, I know when you're daydreaming. When you daydream, I'll come behind you and I'll hit your head really hard. Are we clear? Okay. Then from here, we know that this is under what? Compression. This is under what? Tensile. Immediately, you already know that element B is going to be what? Compression mode. Are we clear? Write this out immediately. Okay. Don't like wait and wait and wait and wait. Nothing happened. Okay. Anything else to do? Nothing. Okay. So then let's view it from the next plane then. Okay. So the next plane over here, I'm going to view this in Y and Z, right? So I'm just now again going to sketch. Right? And I'm going to draw the thing around here, right? And then we have a force pushing here at 1200 Newton. And then you have a force coming down at 1500 Newton, right? And then we sketch again from here. This is our element A, and this is our element B. Then we draw the axis of interest or the center of interest relative to the element. Now, at this view, isn't it very clear that we are going to have a Py that is equal to minus 1500 Newton? Is it very clear? Yes or no? Because it's aligned to the what? Center of interest. When that's the case, it's going to generate an axial load. Are we clear? So from here, we know that again, we have stress Y. This will be equal to Px or Py over A. So when this is the case, element A will be equal to element B, and this will be equal to minus Py over A. It's both in what? Compression. Okay. Anything else to do? Nothing else to do. So from here, we also can see that we have a what? We have a Vz that is equal to 1200 Newton, and it is going towards the right. Okay. Now, we cannot see anything with Px yet, okay, until we have a different point of view, okay. Sorry, Pz. So from here, we also, before I go any further, we have a rotation and an x. So now the 1200 will generate a moment in the what? In the x direction. And now this x direction, the distance is towards the what? Towards the element. And the direction, the distance towards the element is 0.075 meters. This case, you take it towards the element is because the force is perpendicular to the what? To the centroid of interest, yes or no? If it's parallel, if the force is parallel, like for this case, you take it to the centroid, but if the force is applied perpendicular to the centroid, you take it to the element. I highlight this so many times, like a broken tape recorder, or like my mom nagging at me now. Yes or no? Remember that. So this will be equal to 1200 multiplied by a distance of 0.075. Okay, so this is 0. Okay, this is not a. So 0.075. So the outcome from this is equal to 1200 multiply by 0.075, you have 90 Newton meter. Okay. Now, from here, again, we start our analysis. Okay, we start our analysis. So we start our analysis. So we know that the moment the moment will be acting in this direction. Yes or no?